Who is a data engineer? A data engineer develops solutions that facilitate data-driven decision-making. Is involved in all phases of the data pipeline, from the gathering of raw data to its storage, processing, and analysis. Collaborates with data scientists, business teams, and software engineers to ensure that the data infrastructure is scalable, effective, and dependable. Therefore, hands-on experience and knowledge of the technologies that the stakeholders use could be very beneficial in determining the system design parameters, infrastructure requirements, coding and testing pipelines, machine learning models and their environments. Please keep in mind that the responsibilities of a data engineer at each company may vary. Some may focus solely on SQL, some on DevOps, while others could focus on a hybrid approach that incorporates SQL, code, cloud and more. Why is data engineering so hot right now? More and more businesses are becoming data-driven, or making decisions based on collected data rather than gut instinct. To manage and process massive data in the cloud, data engineers create systems that are robust, scalable, and flexible. Moreover, the salary for data engineers is rather high. As of February 2023, the average annual salary for a data engineer in the United States is $135,000. Now, let's learn about the must-know components for success as a data engineer that you should consider adding to your arsenal. 1. Programming languages. Programming languages are sets of instructions and syntax used by developers to write software programs and perform specific tasks on computers. 2. Databases and data warehousing. Databases and data warehouses are digital file cabinets that store data and make it easy to discover and retrieve. Data warehouses analyze historical data, while databases store and retrieve transactional data. 3. Cloud computing. Cloud computing enables you to save, access, and run programs without hardware. Internet-delivered servers, storage, databases, networking, software, analytics, and intelligence accelerate innovation, flexibility, and scale. 4. Big data processing. Big data processing involves employing sophisticated tools and techniques to detect patterns, make sense of large amounts of data, and use that data to make smarter decisions. Big data processing involves analyzing massive, complex data sets utilizing distributed systems and powerful algorithms to get insights and make data-driven decisions. 5. Data orchestration. Data orchestration automates and coordinates data processing operations to achieve a goal. Data orchestration is like a conductor organizing instruments to play in harmony. 6. DevOps. DevOps combines cultural beliefs, practices, and tools to speed up application and service delivery. It connects development and operations teams to boost productivity. 7. Monitoring and logging. Data engineering involves monitoring, logging, and analyzing data system performance and functioning. To increase system stability, dependability, and efficiency, identify problems, trends, and make data-driven decisions. Logging records data and events for subsequent analysis, while monitoring observes systems in real time. Let's find out how well you have understood the use of these components in the data engineering ecosystem. Quiz time. 1. A data engineer's primary role is to A. Analyze data and make business decisions. B. Design and build data pipelines to process and store data, develop machine learning models, visualize data insights. A data engineer's primary role is B. Design and build data pipelines to process and store data. Their main responsibilities include creating efficient and scalable systems for collecting, storing, and analyzing large amounts of data to support data-driven decision-making. 2. Which of the following tasks is a data engineer not typically responsible for? A. Writing efficient SQL queries to extract data, building real-time streaming data pipelines, creating dashboards and visualizations for data analysis, maintaining and updating the database infrastructure. A data engineer is typically not responsible for C. Creating dashboards and visualizations for data analysis. This task is usually handled by data analysts or data scientists, who use the data processed by the data engineers to gain insights and make data-driven decisions. 3. Data engineers are responsible for ensuring data A is accurate and up-to-date, is secure and protected from unauthorized access, is easily accessible for analysis, all of the above. Data engineers are responsible for ensuring data is all of the above. This means that they are responsible for maintaining the accuracy, security, and accessibility of data in the data pipeline, to support effective data analysis and decision-making. 4. A data engineer might be involved in which of the following tasks: A. Implementing data backup and recovery strategies, performance tuning and optimization of data pipelines, developing and deploying machine learning models, creating visualizations for data analysis. A data engineer might be involved in A. Implementing data backup and recovery strategies, and B. Performance tuning and optimization of data pipelines. These tasks are typically part of a data engineer's responsibilities as they ensure the reliability, scalability, and efficiency of the data pipeline, which is critical to effective data analysis and decision-making. 5. A data engineer should have a strong understanding of A. Business operation, as B. Data warehousing concepts, network security, web development. A data engineer should have a strong understanding of B. Data warehousing concepts, and C. Network security. Understanding data warehousing concepts such as data storage and retrieval, data transformation, and data integration is essential for designing and building effective data pipelines. Knowledge of network security is also important to ensure the confidentiality, integrity, and availability of data. Thanks for watching.